Hello and welcome back. My name is Amir and this is Project Euler series, puzzle number 28. So let's see. Starting with the number 1 and moving to the right in a clockwise direction, a 5 by 5 spiral is formed as follows. So we are going from 1 to 2 and then 2 to 3. Then we are going to the left to get to 5 and then going to 7 and then going to 9. And we formed a cube. Then we would go to the right again, 10, going down, left, top, and so forth and so on. It can be verified that the sum of the numbers is 101. So if we can add these together, it would be 101. What's the sum of the numbers on the diagonals in a 1000 by 1000 spiral? So if we check this, we could see that this one is a 1 to the power 2. This one is easy, 3 to the power of 2. And this one is 5 to the power of 2 or 5 squared. So as we go along, each step we would add 2 to our number and then square it. So going from 1 squared, then 3 squared, then 5 squared, and 7 squared, and so on. So this is for this diagonal. But what about the others? If we check carefully, we can see that going from 25 to 21, we always subtract 4. Here we subtract 2, and here we do nothing. So if I am here, I would subtract 2, which is subtracting 3 and adding 1. So in the 3 by 3 we have 3 squared, then 3 squared minus 3 plus 1. And it's the same here. 7, we're subtracting 3, we get to 4, and then add 1, we get to 5. And then same here, we subtract 3 and add 1, we get to 3. The same is here. 25 minus 5, 20, plus 1, 21. 21 minus 5 is 16, plus 1 is 17, and the same here. 17 minus 5 is 12, plus 1 is 13. So we get to a pattern. The pattern is for every square we add 2 to the value, so it's 1, then it's 3, then it's 5, and we calculate it. 5 to the power 2 plus 5 to the power 2 minus 5 plus 1, 5 to the power 2 minus 5 plus 1 minus 5 plus 1, and so forth and so on. So the only thing is that going from 1 to 1001 and adding 2 and do that. So it would be n squared, then n squared minus n plus 1, and again minus n plus 1 for this one, and minus n plus 1 for this one. If I add these together, it would be 4n squared. Then we have 1, 2, 3, 4, 5, 6n, so minus 6n. And then plus 6. So this will be our formula. Right, so for example, for n equals 3, which is this one, we would get to 36 minus 18 plus 6, which is, I believe, 24. So let's add these. It's 10 plus 14, 24. Correct. So I would need this formula. I would just comment it. And then I would need to go from 1 to 1001, add 2, and then calculate this. So it should be pretty simple. So I'm starting with sum 1 to exclude this one and go from 3 to 1001. This should give us the answers. So wow, right, yes, this is the correct answer. This was fairly simple if we figured out the formula to do that. So yeah, the code is on the GitHub. I hope you have enjoyed the video, and see you in the next video then.